Good day, everyone. I am Jeremiah Perez, and I am here to discuss the Group 13 and Group 14 elements of the periodic table. But before we dive into that, let's go over a brief history of the periodic table. As you may all remember, Russian chemist Dmitry Mendeleev was credited for creating the periodic table in the year 1869. Mendeleev noticed that the physical and chemical properties of elements were somehow correlated to their atomic sizes. So he set out drafting a sort of table for the elements, arranging them according to their atomic size. As you can see in the earlier versions of the periodic table, it looks nothing like what it is today, and you may have noticed that there are some gaps in between the elements. This is because Mendeleev predicted that some of the elements are yet to be discovered. You can clearly see that gallium and germanium, two metals that were only discovered in the latter part of the 19th century, respectively, are not in the table at all. Uh, Flashed on the slide is the periodic table we're more familiar with today. So far, we know of 118 elements, and we've already filled up the seventh row. I'd say at this point in time, the periodic table is complete, for practical chemistry at least. But that's not why we're here. Let's begin the actual topic, the Group 13 and Group 14 elements of the periodic table. First, we'll give a brief overview of the Group 13 elements. Group 13 is known as the boron group. This group is located on the right-hand portion of the periodic table, on the side closest to the transition metal block. Take note, Group 13 is the naming convention IUPAC has given for the boron group, though in some instances it has been given the name Group 3A according to CAS naming convention. The elements under Group 13 are boron, aluminum, gallium, indium, thallium, and nuntrium, which has been renamed as nihonium, recently. Elements under the boron group are known to have three valence electrons, meaning they have three electrons on their outermost shell. Another interesting to note is that every single element in the family is a metal, except for boron, who is a metalloid. And that they're properly introduced, let's now go over the individual elements that comprise Group 13. First up is boron. Boron was first isolated in the year 1808, decades prior to the creation of the first periodic table. More notable attempts at isolating pure boron had been done in the year 1892 by Henry Moissan. As of today, the purest form of boron can be obtained by the reaction of boron trichloride with hydrogen at temperatures between 1073 and 1473 Kelvin. On the left, you'll see that boron generally has a blackish-brown color, and is in solid state at room temperature and standard pressure. Based on the table presented on the slide, boron is a metalloid having an atomic number of 5, an atomic weight of 10.911 atomic mass units, a density of 2.34 grams per cubic centimeter, an atomic radius of 0.98 angstrom, and melting and boiling points of 2365 and 4275 Kelvin, respectively. The next element is aluminum. Aluminum was first discovered, or successfully isolated rather, as an ore in the year 1825 by Hans Chris Oersted by heating aluminum chloride and potassium. The first successful attempt at extracting pure aluminum 2 years prior to its initial discovery was credited to Frederick Waller, who used sodium metal rather than potassium during the heating process. On the left, you'll see that aluminum generally has a shiny grayish-white color, and this in solid state at room temperature and standard pressure. Based on the slide presented, aluminum is a metal having an atomic number of 13, atomic weight of 26.982, a density of 2.7 grams per cubic centimeter, an atomic radius of 1.43, and melting and boiling points of 933 and 207 for 2743 Kelvin, respectively. The next element is gallium. Gallium was discovered by de Beaubardin in the year 1875 as he first observed a violet line in the zinc he had extracted. Paul isolated gallium by electrolysis of gallium hydroxide in potassium hydroxide solution. As you can see on the left, it has a solid blue-gray. It is a solid of blue-gray color at room temperature and standard pressure. Based on the table, Gallium is a metal having an atomic number of 31, an atomic weight of 69.723 atomic mass units, a density of 5.91 grams per cubic centimeter, an atomic radius of 1.87, and melting and boiling points of 303 Kelvin and 2673 Kelvin, respectively. Indium was first discovered by Ferdinand Reich in 1863, who stumbled upon it when he first extracted what he thought was thallium sulfide. Analysis of the atomic spectrum showed that the lines were not consistent with the element thallium. The compound was isolated the following year with the help of his colleague Hieronymus Richter. As you can see on the left of the screen, it is a grayish color, a solid of grayish color, and this at standard pressure and room temperature. Based on the table presented on the slide, indium is a metal having an atomic number of 49, an atomic weight of 114.818, a density of 7.31 grams per cubic centimeter, an atomic radius of 1.93 angstrom, and melting and boiling points of 430 and 2345 Kelvin, respectively. Thallium was first discovered by William Crookes when he noticed green spectral lines on an impure sample of sulfuric acid. The first successful attempt at isolating the element was done the following year by Claude Auguste Lamy. Uh, as you can see on the left, it also has a blue-gray color and is solid at standard pressure and temperature. Based on the table presented on the slide, thallium is a metal having an atomic number of 81, an atomic weight of 204.38 atomic mass units, a density of 11.85 grams per cubic centimeter, an atomic radius of 1.93 angstrom, and melting and boiling points of 577 and 1746 Kelvin, respectively. The last element in group 13 is nihonium. The synthetic element is very radioactive and was discovered at around 2003 and 2004 by a team of Russian and Japanese scientists. It should be noted that these teams were discovered nihonium separately, and it was only in 2015 that it was formally recognized as an element. Not much else is known of this element yet, as it decays within seconds and only minute amounts of the element have been created. As such, plenty of the values in the table of properties are simply estimates, as seen or projected on the slide. Due to its fairly recent discovery and its rapid decay after synthesis, there are no known applications of the element nihonium so far. The next group is group 14, which is known as the carbon group. This group is also located on the right-hand side of the periodic table, adjacent to the boron group. Take note, group 14 is the naming convention that IUPAC has given, In some instances, it has been given the name group 4A according to CAS naming convention. The elements under group 14 are carbon, silicon, germanium, tin, lead, and flerovium, formerly known as ununquidium. Elements under the carbon group are known to have 4 valence electrons, which means that they have 4 electrons on their outermost shell. Carbon group also possesses one metal and a metalloid in its series, while the rest are metals. Let's now go over the individual elements of group 14. The first element in group 14 is carbon. While it has been around since ancient times in various forms, it was only officially recognized as an element in the year 1789 by Anton Lavoisier. Carbon can exist as a crystalline or amorphous solid, as in diamond and coal respectively, and on various temperatures and pressures. On the left, you'll see an image of carbon in the form of solid graphite. Based on the table presented, carbon is a nonmetal having an atomic number of 5, an atomic weight of 12.011 atomic mass units, a density of 2.2 grams per cubic centimeter as graphene rather, an atomic radius of 0.77 angstrom, and melting and boiling points of 430 and 2345 Kelvin respectively. The next element is silicon. Like carbon, it also has been around in ancient times as evidenced in the early flint tools that were used by the first humans. Attempts for extracting silicon was first done by Gay-Lussac and Thenard in the year 1811 through a reaction of silicon tetrachloride with potassium metal. The first successful isolation of the element was credited to Berzelius in the year 1824 when he reacted potassium fluorosilicate with potassium metal and some water. You can see on the left that it is a grayish-blue solid as and is brittle and hard at standard temperature and room pressure. As seen on the table on the slide, silicon is a metalloid having an atomic number of 14, an atomic weight of 28.1, 2.33 grams per cubic centimeter, an atomic radius of 1.11 angstrom, and melting and boiling points of 3,823 and 5,100 Kelvin, respectively. Germanium was first discovered in the year 1886 by Clemens Winkler, though Mendeleev had quite accurately predicted its existence. Germanium was first encountered as an ore that was brought in for analysis due to its initial unusual appearance. As seen on the left is a grayish lustrous solid at standard room pressure and temperature. Based on the table presented on the slide, germanium is a metal having an atomic number of 32, an atomic weight of 72.63, a density of 5.32 grams per cubic centimeter, an atomic radius of 1.22 angstrom, and melting and boiling points of 1211 and 3160 Kelvin, respectively. Tin had been around since the Bronze Age in tandem with copper and other similar metals. There are currently no documented accounts as to who or how tin was discovered. Some analysis of the first copper tools discovered or developed in the year 3000 BC were found to have trace amounts of tin in them. As seen on the left, it is a shiny gray metal or solid at standard room temperature and pressure. Based on the table presented on the slide, tin is a metal having an atomic number of 50, an atomic weight of 118.71, a density of 7.29 grams per cubic centimeter, an atomic radius of 1.39 angstrom, and melting and boiling points of 505 and 3160 Kelvin, respectively. Tin, lead has also been discovered in the 7000 BC. Lead nuggets were discovered in Peru and were shown to date back to pre-Columbian era, which was way before the 15th century. There were also documented attempts as to how the Greeks were able to extract lead from ores by smelting. As seen on the left, it is a dark gray malleable solid, rather, at standard temperature and room pressure. Based on the table presented on the slide, lead is a metal having an atomic number of 82, an atomic weight of 207.2, a density of 11.3 grams per cubic centimeter, an atomic radius of 1.46, and the melting and boiling point of 607 and 2022 Kelvin, respectively. The last element in group 14 is flerovium. This synthetic element is very radioactive and was discovered in 1998 by a team of Russian scientists. It was formally introduced as an element on the periodic table in the mid-2012 by the IUPAC. Like nihonium, not much else is known of this element yet, as it decays within seconds and only minute amounts of the element have been created. As such, plenty of the values in the table of properties, as flashed here on the slide, are simply estimates. Due to its fairly recent discovery and its rapid decay after synthesis, there are no known applications of the element flerovium so far.